Welcome to Unit 13, Lecture 1 on the water resources. We already went through some of the basics of water, and as I'm sure you remember, water is also can be known as H2O, or dihydrogen monoxide. And remember, water is a polar molecule. It's got a positive end and a negative end. Looks kind of like Mickey Mouse with the ears being the H's. There's like slight positive charges there. A slight negative charge at the oxygen end. It will form hydrogen bonds to other water molecules. Which gives it a lot of those properties that we talked about in the 30 question packet. Well, now we're going to look at the resources on Earth where water can be found and where people find it to use it. So first off, as I'm sure you know, water is essential to life on Earth. We can live for about a month without food, but only a couple of days without water. And we need a very specific kind of water. All right, what we need is fresh water, which is water people can drink. It contains very little or no salt in it. All right, whereas salt water, ocean water, contains higher concentrations of salts. All right, most of the water we use for drinking in agriculture is fresh water. If you water plants with salt water, you're going to kill those plants. If you drink salt water, it actually dehydrates you, and you will eventually kill yourself if you keep drinking salt water over and over and over again. So it's important to know that we need the fresh water, not the salt water. The water cycle is something we've already talked about before. That is how water gets cycled around the planet, going from its liquid form in oceans and lakes to a gas as it evaporates and goes up into the atmosphere where it will condense into clouds, back to a liquid, little water droplets of clouds in the air, and eventually it comes back to Earth as precipitation. So the big thing about this, to kind of like go look at your old notes if you have them. Alright, water molecules travel between the surface and the atmosphere and kind of know the steps. Alright, and a big part of this is the oceans, because almost all of the Earth's water is in the oceans. Here is just our little picture of the water cycle. Here we have an ocean or a lake. Here we got river. Evaporation sends water up in the air where it condenses into the clouds. Eventually there gets enough water in the clouds, or it hits a mountain range like it does in this picture, and that water falls back to the earth through precipitation. And the whole cycle starts over again and over again and over again and over again. And that's why it's the water cycle. Now if we look at the Earth, about 71%, over 2/3 of the Earth's surface is covered with water. However, 97% of that water is salt water in oceans and in seas, like the Atlantic Ocean, Pacific Ocean, or the Mediterranean Sea, Black Sea, spots like that. So that leaves 3% left. Is fresh water. Of that, over 3/4 of that 3% is frozen in glaciers and polar ice caps. And when it melts, it adds into the salt water a lot of the times, because a lot of the polar ice caps are over areas like Greenland and Antarctica, and then the water melts and flows right into, or the ice melts and flows right into the oceans, which just makes it salt water. So only a small percentage of the water on Earth is liquid fresh water. It's kind of a big problem since we need the fresh water. If we look here, fresh water we use usually comes from lakes and rivers and from a spot beneath Earth's surface. So here's the 97% of salt water. This little slice right here is fresh water. Most of that little slice, 77% of this little slice, ice caps and glaciers, and the rest is groundwater, which is water beneath the ground. It's what lecture 2 is going to be on, and other fresh water. And this other fresh water would be lakes, rivers, and that kind of stuff. So as you can see, there's not a whole lot of readily available fresh water. Well, we're going to break down the different types of water on the Earth. We're going to kind of separate them into different categories aside from fresh and salt. We're going to start with surface water, which is water found on Earth's surface. They busted out the unique name book for this one. So we got surface water, which are all the bodies of fresh water, whether it's salt water, fresh water, ice, and snow that are at the surface. Over the course of history, where water was played a giant role in where people settled down and built cities. All right, we tend to build cities and farms near reliable sources of water, near lakes, near rivers. All right, the Egyptians used the Nile River Delta, which is this vast area of fresh water from the Nile. Mesopotamia was all in that fertile crescent, again, an area of fresh water. Ancient India, the Tigris and the Euphrates, right in there. Maybe that is Mesopotamia. I don't remember my geography all that well, apparently. But either way, if you look, a lot of cultures build up around sources of fresh water, usually rivers, because they're reliable. Nowadays, large cities depend on surface water for drinking water, crops, food, power, and even transportation. All right? People still take boats to get to certain places. All right? And even recreation, like a cruise line cruises on surface water. So, good to kind of know that surface water still gets used today. Some main forms of surface water are rivers. Rivers have played a huge role in human society. And streams from the rivers, as well as melting snow, they drain the mountains, they eventually combine, and they form rivers. All right, a river system is a network of rivers and streams that drain an area. They call it a river basin, but it drains this big, large area. There are many river systems in the world. There's the Mississippi River system, the Ohio River system, which actually the Ohio flows into the Mississippi, so you can kind of see it's part of the same one. There are the river systems of India and China. There's the Nile River system up in northwestern Africa there by Egypt. And then there's the Amazon River system, which is the largest river system in the world. And the Amazon River system drains land that would equal the size of the entire continent of Europe. So it's a giant river system that drains a lot of water, and that's why the Amazon is so big and powerful and mighty. A watershed kind of is where water, I guess I was trying to change the definition around a little bit, but the definition here is pretty good. It's the area of land that is drained by a water system. All right, so any water that falls in this land gets drained away, and that's called the watershed. And as you drive around, next time you drive up toward Lake Ontario or near one of the Finger Lakes or by the Genesee River, you'll see little signs, and they're not big signs, but you can see little signs that say now entering the Canandaigua Lake watershed. And that means any water that falls on the land there eventually, unless it's diverted by like a sewer system, but naturally would eventually drain itself into Canandaigua Lake, so for the Canandaigua Lake watershed, or for the Lake Ontario watershed, anything would drain into Lake Ontario. So melting snows and the rains can increase and decrease the amount of water in a watershed. All right, the more melting snow and the more rain there is, the more water is being drained by the watershed. The more water's in the watershed. At other times of year, dry times of year, there might be very little water getting drained from that watershed because there's just not a lot of water falling into the watershed or melting into the watershed. And finally, here is a map. I believe you have this. This shows you 35 watersheds around the world. 35 of the largest watersheds around the world. And there are more than this. I mean, each lake has its own watershed associated with it. All right? And so if you look, the largest one here in the U.S. is the Mississippi watershed. And that's also the largest river in the U.S. is the Mississippi. It drains a tremendous area of the center part of our country. All right, the Colorado River drains around the Rockies. The Rio Grande River drains around the Grand Canyon area and down through New Mexico, Texas, and the country of Mexico. There's a couple up in Alaska and the Northwest Territories of Canada as well. And you can see other major watersheds throughout the world on this map here. Number 14 right here, there's the Nile watershed. It's a pretty big one. 8 is the Amazon watershed. The Indus and Ganges are 31 and 32, which are what I was trying to think of when I was talking about people settling in India. 23, there's the Fertile Crescent, the Tigris, Euphrates. So yeah, there we go. I got the names, just didn't have the locations earlier. Maps are helpful. So anyway, that is watersheds. They drain water into the river. Any water that falls in these areas gets drained by a river system. The more water that falls on the watersheds, the more water goes into the river system. It varies throughout the year as the amount of precipitation changes. And as we keep going on, we're going to move away from surface water, which is all this right here is surface water, and we're going to move into groundwater, which is water found under the ground, which is the opposite of on the surface. You got water on the surface is surface water, and then you got water in the ground, which is groundwater, which we will be talking about in Lecture 2. If you have any questions, please bring them in, and have a good night.